Here is a program for predictive control using mathematical model of slab and mold wall temperatures. Here we will see the casting speed, steel grade, metal temperature at the entrance to the mold, average heat flux from the mold, maximum heat flux from the mold, water temperature at the inlet to the mold channel. And now, water temperature at the outlet of the mold channel will be calculated by the model and will be shown here. This is the current flow of cooling water to the mold. And I start the calculations. Here we can see the average surface temperature and water discharge for each section. Now the water discharges are not changing because the control is turned off. I turn on the control and the water flow begins to change in order to bring the average temperature in each section to the set value. Now we see that casting speed decreases and how the surface temperature changes. This can also be observed on the surface temperature graph. Water flow rates for each cooling section are presented here. I will place it to that we can see the casting speed. We can zoom in on the part we are interested in. We see how the surface temperature inside the mold decreases and the supercooled part of the ingot appears at the exit from the mold. In response to this, the control system sharply reduces the flow of cooling water in the first section to a minimum. The supercooled part of the ingot moves further, and we see that the control system now reduces the flow of cooling water in the second section. The casting speed increased and the surface temperature of the ingot inside the mold and then under the mold increased accordingly. So the water discharge is increasing here, and then in the second section the water discharge is increasing. This program also allows us to observe the temperature diagram. Here we can see the supercooled part. And here we can see how water discharges have changed. In the first section from maximum to minimum. But still, the surface temperature was not compensated. However, in all other sections, the average surface temperature is constant. It means that water cooling control can maintain the required values. We can stop these calculations and save the current state of the temperature field as tables.csv. Ingot temperature, mold wall temperature, and phase change boundary position.